Hello everyone. Today I shall discuss on mechanical properties of engineering materials. Mechanical properties are useful to estimate how parts will behave when they are subjected to mechanical loads, that means forces or movements. In particular, we are interested to know when the part will fail, or we can say when there will be permanent deformation. Now, there are so many mechanical properties like strength, toughness, hardness, ductility, elasticity, fatigue and creep. Now, what is strength? The strength of a material is its ability to withstand an applied load without failure or plastic deformation. Now, there are many types of strength. One is tensile, another is compressive, shear, bending strength, torsional strength, etc. Now, this one is stress strain curve for a ductile material. Now, within this elastic limit, there will not be any permanent deformation. That means if we remove force, then material will regain its original shape and size. Now, beyond that, there will be permanent deformation. So, if we apply force beyond elastic limit, then there will be permanent deformation, that is a permanent damage. Toughness. It is defined as a material's resistance to fracture when stressed. And material's toughness is the amount of energy per unit volume that a material can absorb before rupturing. So here in stress strain curve, this is stress strain curve for brittle material and this one is for ductile material, and this is your fracture point. So area under this curve, this one, this is toughness for brittle material, and for this one, this is toughness for ductile material. So area for ductile material is more compared to brittle material, so we can say that toughness of ductile material is much higher than brittle material. For example, toughness of mild steel is much higher compared to glass. Hardness. Hardness is a measure of the resistance to localized plastic deformation induced by either mechanical indentation or abrasion. In general, different materials differ in their hardness. For example, hard metals such as titanium and beryllium are harder than soft metals such as sodium or metallic tin or wood and common plastics. Now, the hardness of gold is highest, and in case of engineering materials, hardness of talc is minimum. Now, by a harder material, we can make scratches over a softer materials. Ductility. Ductility is a mechanical property commonly described as a material's amenability to drawing, that is, into wear. In material science, ductility is defined by the degree to which a material can sustain plastic deformation under tensile stress before failure. Now, in stress strain curve, from here we can understand that the elongation for ductile material is much higher compared to brittle material. Practically, if the elongation is within 5%, then the material is brittle, and if elongation is more than 5% before fracture, then the material is called ductile material. Elasticity. Elasticity is the ability of a deformable body, example steel, aluminium, rubber, wood, etc., to resist a distorting effect and to return to its original size and shape when that influence or force is removed. Okay. So in this figure we say that when load is applied over a material, then there is bending. Now when this load is removed, then the material regains its original shape, and this property is called elasticity. Creep and fatigue. Creep is a situation in which a component experiences deformation under constant load. Creep and fatigue are the phenomena that lead to deformation and eventually failure of components. And fatigue is a situation in which component is subjected to cyclic loading. So in case of creep, it is constant loading, and in case of fatigue, it is cyclic loading. Thank you for patience.